Okay, let's dive in. Today we're doing a deep dive into the DVIgear DVI-7318. It's a high-performance 4K HDMI fiber optic extender, and the mission for you, the listener, is to really get what makes this thing tick for serious long-distance video.
Exactly. We're looking at a solution that tackles a really fundamental problem, which is, the physical limits of standard copper cabling.
Right.
When you're trying to push a full HDMI 2.0 signal, you're talking about an 18 gigabit per second bit rate. Copper it really struggles with that over any kind of distance.
And when we talk about the quality here, we mean the absolute top end. This extender supports resolutions up to 38840 by 2160 at 60 frames a second, and crucially, with 4.4.4 color sampling.
And that 4.4.4 is so important. It means no color compression. Every single pixel gets its full, unique color data.
Which is critical for things like, say, broadcast graphics or medical imaging.
Absolutely. It also supports up to 12-bit color and, uncompressed 8-channel digital audio. But the real game changer is the distance.
1,000 feet.
1,000 feet. That's about 300 meters. All over OM3 multi-mode fiber.
So right away, you solve the distance problem. But you also solve another huge issue with long copper runs, which is interference.
That's spot on. Optical fiber is, by its nature, immune to all that environmental signal noise. It has a very, very low RFME profile.
So no interference from power lines, radios, anything like that.
Right. And in sensitive places like a hospital or a secure data center, that kind of signal integrity is just non-negotiable.
Okay, so fiber solves distance and interference. But here's what I find so fascinating. How does it manage to push that massive 18 gigabits of data down a single strand of fiber?
Ah, that is the secret sauce. The DVI-7318 uses something called SWDM optical technology. That's shortwave wavelength division multiplexing.
SWDM. So instead of one lane for data, you have more.
You can think of it like that. It's more like 6 invisible light highways all layered on top of each other, traveling down that single fiber.
6 highways. So we're talking about 6 different specific wavelengths of light.
That's it. 6 discrete optical channels. The source material lists them out. 780 nanometers, 825, 870, and on up to 1,000 millimeters, a whole spectrum of light, each carrying part of the signal.
Wow. Okay, so that handles the video going one way.
Yeah.
But what about the communication that has to go back the other way, the digital handshake?
Great question, because that is essential. The unit is smart enough to support bidirectional DDC signals.
Which lets the display and the source talk to each other.
Exactly. It enables that live, EDID, and HDCP communication. The display tells the source what it can handle, the source confirms the copy protection. Without that handshake, you get nothing.
Just a black screen.
Just a black screen. And they even built in a micro switch, so you can choose between EDID learn or pass-through modes, which gives installers a lot of control in tricky situations.
So if we just kind of step back, what we have is a system built for absolute signal integrity over long distances. It uses this incredibly complex light science SWDM, all housed in a rugged TAA-compliant metal case.
And it has flexible power options too, which is a nice touch. You can power the units from a USB port with an optional cable. Very handy.
So it's a very robust, professional piece of kit.
It is. And it sort of leads to a final thought for you, the listener. If this specialized use of multiple light wavelengths over a single fiber is happening here in this professional space, it makes you wonder, what common devices in your own home might secretly be using similar complex light-based transmissions to speed up their own data handling? It's a fascinating area of physics to explore, especially as fiber gets closer to, well, everything we use.